This is a discussion of how the scientific method was applied in modern science, and we're going to be interested in particular in how probability was applied in scientific investigations in the 19th and 20th centuries. We had seen earlier that one of the aims of science was to escape the naked face of chance by seeing what necessary features of the universe that lay beneath the surface of things cause the mysterious and unknown phenomena that we see with our senses. And we had seen that the attempt to separate the relative and the absolute and to purify the appearances was a way of getting at the real forms behind things that would eliminate the idea of chance. We're going to see that when science turns its eye on itself, that in many ways modern science is going to have to turn to probability in order to explain some of the unknown features of things. And we're going to see that that causes, in many ways, science to give itself back over to the naked face of chance and to explain things by mere probability or mere chance. The first story that we're going to tell in our account of probability in science is the way in which science explained the origin of complex living things, using the nature of probability to explain evolution. Hopefully you've got some understanding already of how the theory of evolution works, but we're going to be talking about the attempts to answer an argument called the argument from intelligent design. The argument from design suggests that there are some complex organisms that are so complicated and so obviously designed that it's a mystery, and that mystery requires something outside of science to explain it. And the theory of evolution was an attempt to use the methods of mechanistic reductionism to solve that particular problem. And we saw that the basic idea of the theory of evolution was to have a system that was set up with the basic properties that Darwin had identified of having inheritance, where the members of a species would inherit properties from their ancestors, so that like begat like. And then there would be a natural variation within the population of organisms. And then if there was a struggle for survival or selection, then the organisms that were better at surviving would survive more and would pass on those traits that allowed them to survive to their descendants. And the species would evolve from the variation by picking out from the variation that already existed those that were more able to survive and those that were less able to survive. And we'll see that idea of evolution as a program to overcome probability or overcome chance is at the basis of the theory of evolution. The basic argument we're going to be considering, though, is an argument from probability, the argument that complex objects are too difficult to explain through mere science, and that it requires some type of non-scientific explanation or intelligent designer or God to explain their origin. The theory of evolution was an attempt to answer that type of argument. So the argument was that complex objects have lots of different parts, and because of those different parts, the probability of all those different parts having exactly the right property all together at one time, given the way that probability works, would be too great. And if we had to pick out one of those possibilities as being the only one that would work in advance, then it would be very improbable to imagine that all of the combinations of those things would arise by the mere blind operation of mechanical reductionism. So when we look at something like Mount Rushmore, we can see that we would say that that had to be done by someone. That didn't arise by the mere random operation of wind and erosion. Whereas when we look at the Old Man in the Mountain that used to exist in Franconia, New Hampshire, before it fell down, we wouldn't say that that had to be made by someone or designed by someone. When we look at this, it turns out that there's lots of rock formations that kind of look like human faces. But why would we say that this requires a designer? It's too complex, but this is not complex and wouldn't require a designer. The random forces of nature will every now and then make a rock that looks like a chin, or looks like a nose, or looks like an eyebrow. The difficulty is putting them all together. So this has very few features that look like a face, very few features that look like a face. The question is whether it's too improbable that all of these features would be put together in the same rock. All of those improbable features would be put together in the same rock to have arisen by mere chance. We think that this sugar bun that looks like Mother Teresa probably didn't require a designer. It has so few different parts that putting together these 4 or 5 parts that look like a human face would have been improbable, but not that improbable. In the same way, we think this condensation pattern that kind of looks like the Virgin Mary on the windows of a bank in Boston could have arisen through natural processes. The theory of evolution is going to suggest that you can explain complex objects, even ones like Mount Rushmore, using the random mechanical forces of nature, if you understand how the program or algorithm of natural selection can overcome those improbabilities. And remember, the argument works by understanding how probability works. If a dice has 6 different sides, the probability of rolling any one of them is 1 in 6. So the probability of a single rock sort of looking like the nose of a person may be very large, maybe 1 in 1,000 times it will happen. But if you've got 5 or 6 different features of the face that have to look like parts of a human face, then the probability will be 1 in 1,000 times 1 in 1,000 times 1 in 1,000 times 1 in 1,000 times 1 in 1,000, or 6 times, or 1 in 1,000 to the 6th power. So if you're flipping coins, the probability of getting heads is 1 out of 2, or 0.5. But if you want to get 2 heads in a row, then it becomes much more improbable, because the probability then is 1/2 times 1/2, or 1/4. 1 out of 4 times you flip 2 coins, you'll get 2 heads on average. But if you want to get 3 heads in a row, it becomes much, much more improbable, because there it's 0.5 times 0.5 times 0.5, which equals about 0.125, or 12 times out of 100 you would expect that to happen. So the more things that have to happen in conjunction, the more improbable something becomes. So complex things that have lots of different parts that only have one correct way of arranging those parts will end up to be very, very improbable, just because of the total number of possibilities and the very small number of possible ways of getting it right. The classic account of this in comparison to evolution was given by Dawkins. He talks about the example of imagining that monkeys typing randomly at a typewriter would eventually type out Hamlet. The number of different keys on a typewriter is about 1 in 50. If Hamlet has about 132,000 characters in it, then the probability of hitting that 132,000 characters all correctly, all in conjunction with each other, is very, very, very small. In fact, so unimaginably small that monkeys typing away randomly at a keyboard would not be likely to achieve that, even given the entire history of the universe. The improbability is much larger than the total number of seconds we've had in the universe, which is about 10 to the 17th. Another philosopher and biologist, Daniel Dennett, has compared this to a story of the Spanish author George Luis Borges, who imagined an infinite library called the Library of Babel. That library would contain, if we imagine that all the books are about 100,000 characters, or about the same length as Hamlet, then there would, and there are the different possible letters or values for each of those characters in the book is about 1 in 50. There's about 50 keys on the typewriter. then the total number of possible books is about 50 to the 100,000th, which is an unimaginably large number of different books. So the chance of, if you were to move randomly through the book library of Babel, the chance of finding a book would be so unimaginably small that you could spend your whole life wandering through the library of Babel without finding a single book that made sense, despite the fact that that library would contain every possible book, including biographies of your life in which you become president, and all the possible biographies of your life that contain all the different possible misprints. So it would contain every possible book that could be written, but it would contain so much nonsense, and the proportion of nonsense to real good things would be so small that the probability of getting any one particular book would be so vanishingly small that if you got it, it would be a miracle. There's an internet version of the Library of Babel, and if you go to it, you can hit a random book from the Library of Babel, and you'll see that it's all completely nonsense. And you could sit there and hit random on there until the end of time, and you would be very unlikely to get one single book that made sense, let alone to happen upon Hamlet. So that's the problem that the theory of evolution has to solve, is that there seem to be things that are immensely improbable in nature. Complex living organisms have so many parts, and the parts only fit together one particular way, that it's almost unimaginably improbable that they could have arisen without some designer or mind behind them. Yet the theory of evolution is going to say that you can solve this problem by mechanistic reductionism without the use of intelligent designer. And the secret to this is seeing how, in fact, the theory of evolution overcomes that improbability by breaking down the improbability, the big improbability, into a bunch of smaller ones and then allowing them to accumulate. Dawkins talks about how he was able to program a computer program to eventually randomly arrive at Hamlet. If you break up the 100,000 characters of Hamlet to one character at a time, each character is only improbable by a 1 in 50 shot. A monkey every 50 times will hit upon the first letter of Hamlet. If we store that through inheritance and then let the monkey work on the second character, it'll take 50 strokes for him to get the second character right. And if we store that and let him work on the third character, he'll eventually get to the third one, and so on. So in a relatively short amount of time, much less time than the entire history of the universe it would take to get all of them right at one go, by breaking up that improbability into a number of small steps, each of which is small enough to arrive at randomly, and then accumulating the design, accumulating the ones that you've got right through inheritance and the survival of the fittest, you can reach very complex things like Hamlet in a relatively short time. So the analog that might help you to understand how this works for evolution is to imagine a sort of a landscape in which all of the different possible ways of arranging an organism and arranging chemicals into life or dead things would be arranged. And this would be gigantic, obviously, more large than even the Library of Babel. And the vast majority of those spaces would be very low fitness. On this graph, low fitness is low and high fitness, things that are likely to survive, would be high. So there would be this vast plane, most of which would be very, very low fitness, most of which would be dead or ineffective ways of combining matter. And in this vast landscape of empty space, there would be just a few of these little mountains, a few of these little high points of high fitness, which are ways of the improbable ways of organizing matter into a living organism that will survive. The mystery in terms of this sort of image is that even though these mountains are infinitely sparsely spread out in this large adaptive landscape, yet we find all of the living species of life accumulating or congregating around these peaks of high fitness. Somehow or other, the unknowing mechanical forces of evolution have somehow found a way to these miraculously improbable peaks of fitness. And the solution can be seen more easily if you imagine how the theory of evolution would work on this landscape. Imagine that we had these little explorer robots that were programmed to move in some random direction and then test to see whether they've gone higher or lower or stayed at the same elevation. If they moved in some random direction, and then if they moved higher, they would detect that and continue to move in the same direction. If they went lower, or if they didn't get any higher, they would set off in some different random direction or change direction. So this is a little robot or a little algorithm that explores randomly and always moves towards higher ground. You can see pretty easily that given enough time, this little go to high ground robot would eventually congregate on all the peaks, even if they were very, very long distances between them. Eventually they would always, since they're always moving to higher ground and always accumulating the high ground that they've achieved in the last step, they would always continue up the hill until they were at a peak, in which case they would never continue down the peak, because whenever they started down they would change direction and always head back uphill. So Darwin's theory of evolution is going to say that that explains how even very, very complex things were put together, breaking the big improbability down to a bunch of small improbabilities, and then continuing on to achieve each of those improbabilities one step at a time. But note that that explains then that how we got to the particular peak that we're on isn't a matter of the essence of human beings or some eternal form that made us what we are. We were dumped onto this landscape randomly by the blind forces of nature, and we've simply followed our evolutionary history, our particular story, up to the highest ground that was accessible to us. So if we're here at this peak, if we started out here, we would go up ground till we got to this peak here. And then we couldn't get to this peak or this peak, because in order to get to that peak, we'd have to go downhill. And our little algorithm only allows for the survival of the fittest. It only allows us to go uphill. If we tried to decrease our fitness, those organisms wouldn't survive and wouldn't be passed on to the next generation. So whereas essentialism, that was part of medieval scholasticism, the view before the scientific revolution, would have held that a human being is a member of an eternal essence, and that deviating from that essence was essentially bad. The modern evolutionary theory would say that human beings are a chance high peak, a chance peak of fitness that comes from where we happen to land on the adaptive landscape, and that deviating from what we are, using medical technology, for example, to change our nature or to alter our genes, might allow us to bridge this gap and get to an even higher plateau of fitness, and that what we are isn't some eternally existing essence or nature, that we're a peak, a more or less equivalent group of population of organisms that are all gathered around one of these peaks, and is only distinguished by a continuum from different organisms and different possibilities on different peaks. You can watch this little video to see how a population would move from peak to peak according to this adaptive landscape theory. So that's how Darwin's theory of evolution explains how we get complex objects, and then has the consequence of giving ourselves over to the naked face of chance, because it turns out that what we are, even though it evolved by mechanical processes, is not an eternal essence. Now what we are now results from the chance starting position we had in relationship to whatever peaks in the adaptive landscape we've moved up to, and it wasn't inevitable that we ended up on that peak. If the adaptive landscape changed, we would be different types of organisms, and there's nothing special about what our nature is now. We could just as easily be something else, and it might be better if we became something else. An objection to this by contemporary advocates of intelligent design has been that there are still some types of complexity that still can't be explained by this gradual process of always moving one step at a time and always making sure that you only moved uphill. There are some things that have what Michael Behe calls irreducible complexity, which means that they only function if all of the parts are there at one time, which means it would be difficult to build them up one part at a time because one part at a time would not serve any function. They sometimes say, what good would be one piece of a mousetrap? So Darwin says that complex things like mousetraps would have to evolve one step at a time, each part arising by random and then being retained because it helped the organism survive. An example would be the flagella of a bacteria. You can see it has lots of different parts, and it will only work to propel the organism if all those parts are there at the same time. So Darwin's theory of evolution would say that they evolved one part at a time, each part occurring by random, and then waiting until the next part came, and waiting until the next part came, and accumulating it like the monkeys would accumulate one letter at a time, retaining each element because it would increase their fitness or move them uphill on the adaptive landscape. Another example is the cascade of different chemical reactions that happen when your blood clots. The details aren't important, but there's a long series of different things that have to happen in order for your blood to clot. If any one of them goes wrong, then your blood won't clot and you'll bleed to death. So it was always mysterious how that could have evolved in the step-by-step process of evolution, because it would only function, and each step would only be retained if you had all the parts working at once. The standard example of this has been the evolution of the eye. Just in the same way you can ask what good is half of a mousetrap, so you can ask what good is half of an eyeball. The eyeball has a lens and muscles and a retina and the optic nerve and all kinds of different features. And yet they would only seem to function as an eye if you have all of those features at once. We'll see that the response that evolutionary theory gives is that indeed each of those features does help, even though it doesn't work as the entire machine until you get all of them. Each of them must have been useful and helped the organism at each of the intermediary stages. So you can watch these two videos that explain how that would have been true for the eyeball. The point being that evolutionary theory thinks that it can explain even these very complex things, even things that only work as a whole, because the parts that were evolved would have been useful for some other purpose. And then when they were all evolved, then they would have been readapted to the complex purpose that they eventually would serve as part of this complex whole. So the idea would be that each of these enzymes that work in blood clotting would have been evolved for some other reason and would have already been useful to the organism in some way, just in the same way that half of an eyeball or impartial eyeballs turned out to be useful, at least for some type of partial vision or adaptive process. So the claim is going to be that the process of evolution can explain these vastly improbable mysteries, and you don't need God or you don't need some intelligent designer to explain them. But the cost of that has been to in some way give ourselves open to the nature of chance, because now it turns out that species arise not as eternally existing forms, but as the result of a historical process that started with random events, the origin of life at a particular starting point, and then moved up according to that algorithm to the highest possible point in the adaptive landscape. This is underlined by the problem of the origin of life, in that once you have replicating molecules, then you can save each step and pass on the design or accumulate the design step by step. But DNA, or self-replicating molecules, is itself very, very complicated. And the replication of DNA had to evolve in the period between the origin of the Earth 4.5 billion years ago and when life arose about 3.5 billion years ago, in a relatively short period of time. You can see that the problem here is that DNA replication itself is a very, very complex thing. So it's still sort of a mystery. We don't yet have a fully, even though every biologist assumes that life arose by mechanical processes, we don't yet have an acceptable theory that's accepted by everyone of how this complex process could have evolved by merely random chance, because no biologist would think that a DNA molecule could have just happened to come together. They would think that it had to evolve through some step-by-step historical process, and that there must have been some other smaller self-replicating molecules that we've yet to discover that gave rise to the complicated process of replication that we see in DNA today. So you can watch that video to see how complex that process is. But this will highlight the next topic that we'll talk about, which is, are the starting points themselves of life, the random starting points of life and the random starting points of the universe themselves, so improbable that they require some type of explanation that can't be explained by science itself? Does the fact that we live on a planet uniquely situated near the sun and not too far from the sun, and that there are such things as planets and solar systems, does that itself require a type of explanation that science can't give? And that'll be the topic of the second lecture.